All right, 2018 number 6. Consider the differential equation dy dx equals 1/3 x parentheses y minus 2 the quantity squared. A slope field is given below. Sketch the solution curve that passes through 0, 2, and sketch the solution curve that passes through 1, 0. All right, I am going to try to draw on here. That passes through 0, 2. They've helpfully labeled the points for us on there. But that's just going to be this horizontal line right there. The one that passes through 1, 0 is this point right there. So we'll kind of follow that way, and we'll kind of follow it there, and it goes back up again, and something like that-ish. Something like that. So that's our solution curve. That's what the function would look like. Let y equals f of x be the particular solution with the initial condition f of 1 equals 0. Write an equation for the line tangent to the graph at x equals 1. Use your equation to approximate f of 0.7. Okay, so we have two things to do. First is to write the equation of a tangent line using this point and that slope. Well, I mean, we can figure out the slope from the, we'll just plug 1 and 0 in for x and y there to get the slope. And then, once we have the equation of our tangent line, we will plug in 0.7 for x to find an approximate value of the function. Alright, so, b. Okay, so y minus y1. Alright, so our point is 1, 0. So that's going to be our x1 and y1. Our slope, whoops, can't quite see that, but our slope is going to be 1/3 x y minus 2 squared. So we plug in 1 for x and 0 for y. 1/3 times 1 is 1 times -2 squared. So that's 4/3. Alright, so x is 1, y is 0. Y equals 4/3 x minus 1. That's the equation of our tangent line. To approximate the value, we'll plug in 0.7. So this will be 0.4, -0.4 basically. Right. Alright, C. Find the particular solution y equals f of x to the given differential equation with initial condition f of 1 equals 0. So now we're not just asked to kind of draw this line and figure out what this value is. We're asked to actually find the equation for the pink, magenta, purple, whatever you want to call that line. We're going to need to set up a differential equation. Well, we have a differential equation. We're going to need to solve this differential equation by separation of variables and, you know, all that other fun stuff. All right, so we have C. Dy dx equals 1/3 x y minus 2 squared. Okay, get the x over there, get the y over there, so we have y minus 2 to the -2nd dy equals 1/3 x dx. Take the antiderivative. In this case, it's going to be add 1 to our exponent and divide by the new exponent. So we'll have over here, we'll add 1, we'll get -1, and divide by -1, but whatever. Uh, 1/6 x squared. We have a plus c on this side, but we subtract it and get our new constant, yada, yada, yada. Now, we got a couple ways we can do this here. Let's just clean it up a little bit. We're going to want to solve for y. So that's going to kind of have to be our first thing. Multiply by this denominator, divide by that is essentially what we're doing. And then divide by that. So we'll have -1 over 1/6 x squared plus c equals y minus 2. So we'll just add 2. Alright, so here's our function. We know x equals 1, y equals 0. Maybe it would have been easier to solve for c before. Actually, probably. Whatever. -1 over 1/6 plus c plus 2 equals y. So we need to get this to equal -2, which will happen when this is 1/2. So c is 1/3, right? Yeah, okay. So y equals -1 over 1/6 x squared plus 1/3 is our final equation.